and I think everything is right now fine. So let's continue our discussion. I find that some students drop the course. This is fine, no problem. I still have like 35, but for the time being, I'm having 31. There are some apologies. The reason is that they came to SKIU to collect their books, and they are right now back to their homes, and they couldn't come or join the meeting for today. Today's tale is like an introduction, so don't get worried about the content. These are, I believe, mostly general knowledge. You already know about earthquakes. We will not go into deep topics, but let me get the slides. You will lose the connection, or sorry, my voice for a while, but don't worry. Do you hear me again? Guys,
Yes, doctor.
sorry about that. I was
It's
saying that they only have two ports in this laptop, so I had to disconnect one of them to get my slides. Do you see the slides right now?
yes. Doctor, can you please lower the sensitivity of the mic because it collects noises surrounding you?
Uh, what do you mean? Oh, I got the point.
So,
Sorry.
yeah,
What
it
should I do?
collects.
What should I do
Uh,
again?
Lower the sensitivity of the microphone because it collects like in
Mm,
everything surrounding you.
let me check video capture. Checking, checking. Oh, this mic is already off, so I'm using the only one mic. Okay, that's the mic I'm using. Let me check the mic I have in here. Probably they are interfering with each other. Setting, speaker, mic. Yeah, that's right. I'm not sure how I can do that, but I can increase the resolution of the video output, or this might be better. So my plan for today probably is just to speak in front of you, but from next week onward, I will be casting in here. So let's do it very quickly and see how it works. Actually, for general geophysics, they were not very happy with the setup for some reason. I have no idea why. They said the resolution is really bad, but that time I forgot to bring my webcam, so I was video recording using the built-in webcam, and the resolution with the built-in webcam is really bad. It takes some time to get it on. I mean the projector. It is started working, so let me try if I can get my PC contents. Yes. Let me do some other thing. Let me see, where am I? Where is me? Yes. How is it? Okay, I got forgot. Oh, how is it? What do you think? Is it clear?
No, doctor.
Okay, it's not very clear. Let me switch on the lights, see what happens. No, it's worth, I believe. It's not clear at all. Am I right? Uh, how is it right now? Do you see the slides?
Shut down, Doctor.
Sorry,
It shut down.
I couldn't hear you.
It is shut down. Now, it's good.
Do you see the slides?
Not clear,
We'll
Doctor.
see, but it is not clear because of light.
Let me switch off the lights again. Let's see what happens. How is it right now, guys?
Mm,
The same, doctor, is bad. You cannot see.
Really?
Yeah.
yeah.
Okay, this is really something I have.
Mm, maybe if we put it far away a bit, it will be clear.
What should I do? Bring it closer because I have only one monitor. I can't see both things. I cannot see what's going on. What you were saying? What should I do?
Put it far
Doctor,
away a bit.
Shall I
Bring it back. Yeah, the
keep it,
camera.
bring it front or keep it a bit away from the screen?
Oh, away, away.
Away?
Yeah.
Doctor,
Yes.
what about showing the slides? It is easier and clear.
Maybe I want
Just
to
show.
draw something. Maybe I want to speak. Maybe the language, the body language, gestures, they like make a difference, while presenting.
But actually, we cannot see the slides from like this.
Okay, I will go the way you say. No
Doctor,
problem. Uh-huh.
why you do not use the presentation in the Google Meet?
Some people they're saying they would like to see me too.
We can use the same too, doctor.
No problem. We'll go the normal way, the way we were doing last time. So let's start our lecture. This is still a bit introductory. Hide the preview view. For this week, it's still introductory. We are left almost with an hour. I might not finish it, but for today, it's a simple theory part, and we'll be having a lab session in 2 days. The lab session gonna be interesting because we'll talk about stress and strain and how we image them and how we like plot them. This is a very interesting thing, and it's not just related to geophysics. Understanding how stress and strain are related. They are having usage in like in mechanical engineering, in civil engineering, in geology a lot, in structural geology. especially the one who want to specialize in structural geology and know a bit more in structural geology. Stress and strain is very important. That's the basic components or basic foundations of earthquake seismology, understanding the stress and strain regime. When I did my courses in here, like in seismology or in apart from seismology, other courses like applied geophysics course, it's supposed to be a seismic related course, applied one, but I never studied stress and strain, and I never studied how I can plot them and how I understand them. Let's assume that you want to be a geomechanics in an oil industry. It has a lot of application nowadays in PDU and other companies in Oman being expert in geomechanics. Geomechanics is mostly about stress and strain, how you incorporate them into geological framework, into your reservoir framework. So we'll touch a bit, we'll not go into deep. We use two techniques. You do it by hand, and I do it by Python with some data. Then I ask you to do or follow the same steps I did, but using different data sets. This gonna be like a refresh to you how to use Python. The one who already probably know something about Python or programming in general. And for those who does not have an idea about programming, it can be an introduction to learn a bit about Python. But as I said, you just follow the same steps I do, but with different data sets. And then you will find how it is easy to do things using programs instead of doing hands. And instead of writing the solution by hands. Programs that will simplify the things or your task, simulate your task. For many either geological, geophysical, petroleum engineer, or other specialization in engineering or science, they can't be done except by computers, by programs. So for today, we'll talk about earthquake. I introduce you to the earthquakes. We talk a little bit about stress and strain. Governing equations in stress tensors gonna be in the lab part. Principal stress component, we'll discuss that also in the lab part. And the exercise itself is how to draw something called Mohr cycle. Mohr cycle tells you when at what stress area or stress pressure you put to the rock, it will breaks. It's not only applied to rocks, but many different things. They use it in civil engineering. They use it in many different disciplines. Mohr cycles is some of the basics of like understanding how rocks or other materials behaves and apply the stress. So what is an earthquake? How I can define an earthquake? Earthquake in the context of geology is a sudden or a rapid release of energy. That word sudden is very important. So the energy is released in very short time period, within like seconds. Then we can call that thing an earthquake. The energy is released within a short time span and it's really huge energy. The energy is manifested as seismic waves. So it generates seismic waves. The seismic waves they radiate in all direction. And we say present is the key to the past. I believe you have already know this phrase or sentence from Geology 1 probably or Geology 2. How we can tell that there was an earthquake in some place? Malik, Malik, do you listen to me? Can you hear me, Malik? Is he around?
Yes, of course.
What
Yes, I'm around.
what do you think? How you can tell that there was an earthquake in the past somewhere? Being like a
We can
geologist.
look, yes, we can look at the fault system of the
Yes,
region.
yes. Faults usually are the key that there was an earthquake sometime during the past episodes or ages. But since I said sudden, you might think, okay, if the energy is released within a long time period, not being released suddenly, what happens? There is a term called seismic creep. There is an associated change in the earth structure, maybe a fault, maybe a bending or whatever, but there was no energy, no huge energy released. The reason is that, let me ask you, what do you feel if you suddenly run very quickly? Are you going to be exhausted? Yes, you're gonna be exhausted a lot. You might, if you haven't run since a very long time, you might have a tension in your muscles. Means that you have released huge in a within short time period. But in contrary, if you walk slowly for like longer period, then nothing. There is you feel no exhaustion. That's the same principle in here. So the energy is supposed to be released suddenly within short time period, whole of the energy. But those seismic creeps, they release small amount of energy in certain time, and the energy is kept releasing uh, during a very long time period. So that's the principle of seismic creep. Seismic creep is very important. For example, in nowadays in oil industry, they want to relate uh, the fractures when they inject something to the reservoir. They want to understand how the reservoir behaves. You know, when you are injecting something to the reservoir at high pressure, what happened? What's supposed to happen to the rock? It's supposed to break. You might try to avoid the break. It might be one of your objectives to the reservoir. You want to keep the pressure, but don't make any faults because the fault might like break the seal and the oil escape. This is a scenario. It's very important in such cases that you understand that there is no seismic creep. So seismic creep might even still create fault, but without associated earthquakes. This is a very important point. I want to mention it and highlight it in here. So stress and
Doctor, I have a question.
yeah, go ahead.
Can we say that the seismic creep is the opposite of an earthquake?
Yeah, probably yes. What in terms of opposite, how I can define opposite in this context, but yeah, you might be
That
right.
it's not sudden.
It's not sudden. Yes, that's the reason I highlighted that word, sudden or abrupt change. So when exactly an earthquake happens to a material, when there is a break, when that break happens, when the fracture happens, let's assume that you have a pen. I'm not having a pen, I have this pointer right now. Let me ask you another question. There are different type of stress you can make. This is a tensile stress. This is a compressional stress. When I try to, do you see that one? This is a compressional stress. This is a tensile stress. All mostly most of the material, they are very sensitive to tensile stress. They break easily with tensile stress. Whenever you want to break a pen, you might do like tensile force stress on the rock or on the pen itself, but you don't want to compress it. You don't want to change the size. So shearing, this is, we'll cover that one later on. But at some points when I do that, or to my phone, it will rebound. It will return to its original phase. Do you see my mouse?
Yes, doctor.
Oh, that's good. This is perfect. So that area called elastic deformation. That's called elastic deformation. Why is that? Because Earth in this region, on this strain, it will return to its original shape. There is no change to the shape of the material. at some point start changing, but still there is no break. Start to change its shape. That's the ductile deformation. It's a permanent change. So when I release the stress, uh, there is some change. So we'll talk about this during the lab and how we represent them and how we plot them. And we take some case examples from sample of rocks. At the point when the strength of this material, whatever it is, it breaks, it cannot withstand the stress I'm putting to this material, it will fracture or breaks. That's the point where earthquake happens. So what is exactly earthquake in this case? This is exactly the same energy I'm putting to this material. That energy is transferred from my hands to breaking this one. But in the sense of geology or seismology, the energy travels as seismic waves in all directions. And the distractions we see usually they are because of seismic waves. Is that clear? So there are three phases of stress and strain relationship. We'll go study these three phases during our lab session, and you understand how you make interpretation of stress and strain. There is not much mathematics. The mathematics I bring are very simple mathematics. Whenever there is a complicated mathematics, I will try to avoid it. The reason being this course is very introductory level in geology and geophysics, or even petroleum engineers taking this course. So what are different nomenclatures? What are the terminologies associated with earthquake? So the focus is the most important terminology. There is a synonym or acronym to focus. What is that? Who can tell me? There is another word to focus, which is called epicenter.
Hypocenter.
Epicenter, hypocenter, even. Yes,
Hypocenter.
sorry, hypocenter. Focus is hypocenter. Epicenter is the projection of that point to the surface. Whenever I talk about epicenter, the seismologists, the people who are working for earthquake monitoring, they care about the surface location, XY location. Other like petroleum engineers, they usually try even to get information about small earthquakes. They care about hypocenter or the focus. Whenever there is the term focus involved in my discussion, I need to bring three parameters: x, y, and z. That's the initial point of rupture. And the hypocenter is the projection of that vertical projection of that point on the surface. And we see the fault plan, and we see also fault trace. Fault trace is simply a line. Fault scrap is the surface expression of the fault face. That's what you see on the surface. Fault plan, part of it is under the ground, and there are also seismic waves associated with the release of this energy. So these are the terminology usually associated with the earthquake. We try to understand or try to locate where the earthquake happened, and we try to get these two parameters, epicenter and the focus. Knowing the epicenter is way easier. When you do calculations, manual calculation can bring quite easily the epicenter, but hypocenter or the focus is more difficult to calculate or to know in seismology in general. Why earthquake happens? Why there are earthquakes? It comes back to a recently newly developed theory, which was developed in late 1960s. You probably have studied that or covered it in slight like discussion in Geology 1 or Geology 2. That's called plate tectonics. So the image you see, it's on my right side. Those are earthquakes. They have a common pattern. They are like not randomly scattered along the surface of the earth, but located at certain bands. Have you heard of ring of fire? Ring of fire.
Yes.
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 Yes, so this is called ring of fire. There are a lot of volcanoes activities in these areas, and the earthquakes usually happens where there is a plate boundary. So most earthquakes they happen along plate boundaries. However, there are still intraplate earthquakes. Those are earthquakes which happens inside the plates, but they are not that common. They might be very high in magnitude, but in comparison to the one which happens along the boundaries, they are lower in amplitudes. They might be also associated with volcanic activities, so there might be earthquake whenever there is a volcanic activity. There might be also associated with meteorite impact. When something from outer space hits the Earth at high velocity and the size of that a meteorite is very big, we assume that there's gonna be an earthquake, a big earthquake probably. So meteorite, they have the potential to generate high magnitude earthquakes. The term magnitude, I bring it quite often, but we'll explain it more in detail in the chapter when we talk about magnitudes and how we define the magnitudes and how we calculate them. Do you remember just recently there was an explosion, a big explosion, shocking explosion in an Arabic city, very popular Arabic city called Beirut. Have you seen that footage? I believe yes. That
Yes.
Yes.
yes, it was widespread in media. Everyone was talking about that footage and the event itself. You know that it created a magnitude 4. It's quite big magnitude that can damage buildings. So human usually feel whatever whenever the earthquake magnitude is above like 3 or 2.5. Anything is below 2 or 1, we usually name it we micro earthquakes. Micro means small earthquakes, but we'll cover these topics again later on. Let me be a bit faster because
Doctor,
yes, go ahead.
so in fault, it is not an usually indication. Yeah, it's not always indication for an earthquake because here you mentioned another causes of earthquake.
Yes, that's true. But the probability of earth faults causing earthquakes is really really high. يعني let's assume explosions. Explosions, they are just recent things in human history. Nuclear explosions, when there was no nuclear explosion or big explosion, people were fighting with swords like 200 2000 or 200 years ago. So maybe meteorite impact is possible, but the likelihood of meteorite impact is very low in compared to earthquakes. Earthquakes are related to plate tectonics. Plate tectonic is very active thing. It's changing the shape of the earth. Even like small movement in the plates with respect to each other, they create huge amount of energy, stored image
Yeah,
energy.
doctor, this is something surprising because what we studied that the plate tectonic is and it's happening very slowly and the earth is moving very slowly. So
Absolutely.
how this slow move can cause a huge releasing of energy?
Because of the volume. Yani the plates volume are huge. We are not moving simple car. We are moving, not me, the atmosphere itself, the blooms in the atmosphere. I will not go to the idea of plate tectonics, why the plate tectonics happens in detail, because I believe you will study this again and again in other courses in geology probably. But the volume of that plate is huge. It's tremendous. Whenever there is a small movement adjacent to another plate, there is a huge amount of energy stored. And when it releases as an earthquake, the damage or the seismic waves are really, really huge. They prop all the earth. They can go from Oman to USA. The seismic stations or equipment in USA, they can record those signals. I hope the point is clear, but
Yeah, that's clear.
and there is something very recent,
Doctor,
which yes, go ahead.
I think we can simply explain this by the magnitude or the power that caused because of the earthquake and the plate tectonic is very big. It is about maybe Newton's second law, F equal to AM. So if
Yep, mass.
yeah, if the mass is very high, so the A is very low and the magnitude is will be high as
Uh,
well as the
no, but do you remember when I said there is a movement, a sudden movement? Do you remember when I
yes,
said, yeah,
yeah,
the energy will be released whenever there is that sudden movement. That's the
okay.
brittle phase. In that brittle phase, that movement, the acceleration is quite high actually. And it's not that much high, but it's relatively high. We'll come back to that in some whenever we talk about the risks or hazard assessments. That might be at later chapters.
Okay.
And there is something very recent and it caught the attentions of the community and the media. And it's related to the drilling and pumping, especially hydraulic pumping. The reason being that now they are trying to relate what earthquake happens in some areas, especially in US and some part of Europe, because of the injection and drilling activities. It happened in Oman. Have you heard of Fahoud field, for example? It's very popular field in Oman. It experienced some damage and subsidence, and people on the surface they kept feeling earthquake, and that changed the mind of how PDU nowadays operates. Yeah, they changed the activity types, and they changed their how they operate many different fields, not the traditional way. The insights or the field development plan totally changed. They spend more time on understanding how to correlate geophysics with geology, with geomechanics, with petroleum engineers to avoid such damage to the surface. Because earthquake, by the way, yani, have you heard of normal fault? You don't want to break your will. You spent millions of dollars on a will, and if there is a break, a fault which can cut across the will gonna be damaged, and you will lose your equipment. So those things are quite often because there is a natural pressure there down the ground where the reservoir is. You are depleting the reservoir, so you are changing the poor pressure, the pressure which is from the in the pore of the rock. You're changing that pressure that might be associated with earthquakes. That's the reason some countries actually, not companies, they're enforcing oil companies, to do like regulations, to follow some regulation they set. They ask them to monitor earthquake activities continuously, like whenever they are drilling or pumping something to the to the reservoir, they have to monitor exactly what type of earthquake and what is the magnitude and how frequent they are, those magnitudes or those earthquakes. And whenever they're like magnitude is above a certain limit, that limit is different from a country to a different country. In Oman, we still don't have such regulations, but in UK and USA, Canada, there are a lot of hydraulic pumping activities going on, especially in US. And you know that one of the reasons why oil prices went down is because US is producing nowadays a lot of oil from shale gas. What's that? I never seen this thing.
Doctor, when this happened exactly in drilling? يعني drilling what kind of pumping, what kind of things, pumping water, what?
For
And it is
example,
really happening here in Oman.
yeah, it's happening.
People feel earthquake.
They felt it quite a couple of times.
Oh, this is amazing.
Yes, they felt it on the surface, like in Fahud, in several other fields, they felt it. It's quite expensive. The companies try to avoid it, avoid the monitoring because you want to just drill and pump without doing any monitoring. It's dangerous. The reason being, for example, there was a case in Brazil, BP company or some other company. It's banned for I'm not sure how long, but it's banned because there was a spill, oil spill to the ocean.
Deep Horizon,
Huh?
BP. Deep
BP.
Horizon, BP.
Yes, because there wasn't any proper monitoring. You need to monitor, and then an small earthquake happened. That was because of a fault. That fault actually break through the seal. What is a seal? Actually, it's the cap rock. The rock type which is impermeable. It caps the reservoir or does not allow the oil to escape to the surface. So it break through that, and there was an escape of hydrocarbon to the ocean. And the damage was really huge. They couldn't stop the spill for a very long time. So we need to be like very cautious about these things. And one of the techniques they are deploying in oil fields monitoring is the same technique we use actually for earthquake detections. The principle is the same, the mechanism is the same, even some softwares they are the same. And let me say for sure that in PDU, for example, there are not a lot of people who are within this specialization. If someone graduates having good specialization, understanding how to locate earthquake, what are the magnitudes, how I can interpret the magnitudes, how I can relate these things. We will not go to that detail, how we can relate like these things to the geomechanical aspects. That's not the scope of this course, but those things are very important. We are left actually, I talk a lot. Not sure I'm deviating, no problem. Where earthquakes exactly happens, how I can differentiate earthquake in terms of their depth. They are shallow earthquake. Usually the earthquake, as I said, happens along plate boundaries. One of the common plate boundaries is the one you see. Who can tell me what type of plate boundary is this?
Is
I,
it
w- I want a new voice, someone who haven't heard, because they are someone might be who is very shy. Huh?
Convergent.
Convergent, yes, this is a convergent boundary. There is a subduction zone. That's the subduction zone, subducting beneath the crust. The crust, usually the oceanic crust, is denser, and the continental crust is lighter. That's the reason the oceanic crust dips beneath or sinks beneath the continental crust. And all earthquakes mostly are associated within this slab. So they happen along this. The thrust earthquake less than 50 kilometers, some of them within from 50 to 300 kilometers, and some of them they are very deep. So earthquake usually they happen within the earth, within the crust and the upper part of the mantle. We can assume that it's still the asthenosphere, part of asthenosphere and lithosphere. But there is a point in here. Which earthquake you think is more damaging? The deep one or the shallow one?
Shallow one.
Another one.
Yeah, certainly shallow one because they are simply closer to us.
Surface wave.
Yeah, that's one reason. Yes, surface waves. Wow, you seen my slides or something? Because there is a
Depends.
huh?
It depends on magnitude also.
It depends slightly on magnitudes too. In this case, but for the same magnitude, if we assume that there are two earthquakes, one of them is very deep, the other one is shallow, with the same magnitude, the shallow one gonna be more destructive. The concept behind that, one of them is, as one of you said, surface waves. Surface waves they travel within the crust. They can't travel deep. They don't travel in the interior of the earth. So how much surface waves generated with those earthquake associated or happened at a deeper part of the crust, they are not associated with higher number of large number of surface waves. Another part is attenuation, يعني, and the geometrical spreading. What I mean, because the earth some part of that energy gonna be transport or translated to heat, because it's simply a friction, rock friction. So at larger distances, mostly the energy have already been converted to heat. And you know that the larger the areas, and I'm having a force or some energy. If I distribute it in smaller area, the damage is large, or the energy density is very large. But when I distribute the same amount of energy on a larger area or larger volume, in this case the earth is a 3D basically, then the energy density is way lower. So whenever the spreading of the seismic waves travel farther away, the energy gonna get lost, and the amplitude of wave will lower down because of geometrical spreading, and the other thing is attenuation. Don't need to know them, but these are some terms in geophysics, especially in seismic techniques. We, yeah, we not sure whether we go through them or not in this course. What are the wave types? I believe you have studied this in general geophysics. You have taken the course. Some of you are taking the course right now, so we'll cover these wave types in more detail. One of the wave types is called P wave. By the way, they're both of them, P wave and S wave, primary and secondary waves. They're surface waves, or sorry, they are body waves. They travel in the interior of the Earth. They can probe even the core of the Earth. The P wave is the fastest wave. It's the first to arrive at the station. One characteristics of these waves compared to the other types, the surface waves, is that they are high in frequency. The frequency is really high. We'll come back to the frequency concept in here later on when we talk about magnitudes and other things. And also, yes, we'll come back when talk about magnitudes, earthquake magnitudes. S wave is the secondary wave. It arrives later, but you see the sense of motion for the first one. The particle keep moving in the same direction as the wave is moving. They keep pushing and pulling the particles in the same direction as the wave moves. The S waves, they move the particle in probably two different directions. One of them is up and down. We call that VS, velocity. V stands for velocity, S is S wave, then V vertical. So it moves either in this way or even in this way, يعني horizontally or vertically. The horizontal component, we call it VSH. You might hear these terms, especially the geophysicists, when they do higher courses. One interesting thing about S wave is a shearing wave. Whenever I say S, it's trying to shear the rock. It's not trying to compress the rock, change the volume. No, change the shape. Can I change the shape of liquid? No, liquid can have any shape. يعني I cannot say a liquid have a certain shape. No, liquid can be any shape. So you cannot tear the liquid. You cannot ما نقدر نمزق الماء. So the shear wave does not travel in the liquid. And that's one of the reasons people discovered, or scientists discovered, the outer core, that it's made of liquid. It's partially melted because the S wave, no S wave, there is a shadow zone, a zone from which S wave does not come. There are no records of S wave. So they assume that there is a part of the earth which is liquid, and they know that this is outer core. So this is one of the applications of geophysics, and how we can use the geophysical methods or information to know more about the earth interior. There are other two types also. Why they are not moving? Okay, I need to update these two. There's supposed to be animation with them, but for some reason I'm not seeing the animation. They're called surface waves. They travel through the crust. They are lower in frequency than body waves, but their amplitude is way, way higher. This is one of the good characteristic. You can differentiate between body waves and S waves. Their period is way higher, يعني way longer, sorry, not higher, but the period, the time span for surface waves is way longer. Love wave, the first one, is faster than the Rayleigh wave, but the Rayleigh wave is the one which is more destructive. It's the most destructive type of wave, and it's the one responsible for the damage in the earthquakes. I need to do some changes in here anyway. Earthquake records. So this is the one you see on here on the upper part, top left, top right, sorry. It's a record. So we see three seismograms, three different traces. And usually this is how they represent the trace. This can be, in this case, it's displacement, how the earth moving, how much it moved. So it's supposed to be like in centimeter or millimeter, how much millimeter moved. I will not go to detail how they convert those data or the instrument data to displacement. But my question, why there are three? Why there are three even though this is the same station, one station? Why I'm getting three different readings?
Because of the frequency of each wave.
Because of the arrival time.
Because
No,
it travels as a wave, so each wave it will arrive in
no.
certain.
Okay.
I think to locate the center for earthquake.
Huh?
Three
To locate
earthquakes.
I couldn't hear someone was talking because his voice was disconnecting. Can
to
you repeat?
locate the for the, to locate
Uh,
the epicenter for
no, not necessarily, but somehow yes. That's one of the reasons. That's a very good question. And you to try to locate the earthquake. This might help. And in the same station, instead of using only one sensor, which is vertical, I use three sensors. Vertical, one in this direction, and the other, they are perpendicular to each other. Not necessarily one of them is pointing to the north. It's very not necessary at all, but they're supposed to be perpendicular. It's best that they are like the horizontal one are very horizontal. The reason is that you need to know more about the characteristics of the earthquake, from where it's coming, what its shape, what more information I can get from more than one sensor. So each one of them is recorded by different sensor. Another thing, when I do some type of processing, I can tell which one of them is V S wave, which is horizontal, and which one is VS. I can know which one is VS or V vertical, sorry, and which one is the horizontal. This is called seismograms. The record themselves, they are called seismograms. They are usually represented in such manner. This can be, in this case, this is displacement, but I will not go into detail. They can be even velocity, by what velocity the earth is moving, or they can be even acceleration. You know what's acceleration? This is in terms of time. So as you see, it's 30 seconds. 30 seconds is very, very long. Was it in this lecture or the other lecture? In whenever I'm trying like to do exploration geophysics, exploration seismic, like image a layer at a depth of 2 kilometer, My maximum recording time is about 3 seconds. It cannot exceed 6 seconds in exploration seismology or exploration geophysics when I try to image the subsurface for oil exploration. In these examples, I'm recording up to 30 seconds. We'll not go to details, but this is just some representations. And here they're trying to locate the P wave and the S waves. You see, the P wave is quite hard to pick, but it probably is easy. This is the picking process. So you do that yourself. I give you some traces. You try to locate where exactly is the start of P. Where is the start of S? So all of this energy from here up to the start of S, they call it P wave. This is the S wave. Then what comes? What do you think is this?
Surface wave.
Those are the surface waves. How I can compare them? You see the amplitudes. You see this is the amplitude, how much it goes up. That's the amplitude. Their amplitude is way higher than the S waves or the body waves in general. And P wave is easy to pick. I go back to the same discussion I was in because it arrives very quietly. There is just like random noise or no prior any waves before P wave. So it arrives, you can easily detect it. You might not detect it by eye. It's not easy, but software computer, they built some automatic picking. They can easily get the P wave. S wave is probably might be harder because it comes after the S wave. Maybe the P wave haven't finished, then S wave is coming. So part of S wave is also P wave. And the surface wave, usually the start of them is not easy to pick when they start. So it's not very easy. Maybe it's in here, You can do you see my mouse?
Yes, yes.
Good. So if you make a good guess, you say, okay, that's the start of S waves. We don't care too much about the start of S wave. We care more about start of P and S wave. So not sorry, not surface waves. We don't care too much about what is the onset of surface waves, especially in local earthquakes. But in deep earthquakes, we might care very deep, far earthquake. The one يعني which is coming from USA, those one we care. For what? This is not the scope. Maybe for this lecture, we discuss it later on. The equipment which record the seismogram or the seismic waves, it's called a seismograph. This is very old type of or it's just like schematic overview what is the principle of these equipments. You are seeing uh, a ball hanging from something on a rope, and whenever there is a motion, because this is fixed, this is very fixed to the ground, this keeps shaking. Whenever there is a shake, it keep records the earth motion. So the old instruments were having some principle similar to this. New one, new one are more complex. We call them seismic stations. They have self-operational techniques. They don't need human interference a lot. They keep sending the data continuously to the processing stations or processing offices. In Oman, for example, we have earthquake monitoring center. It's inside SKU. We'll do a visit there once. So this is the earthquake monitoring center. What you see here is the map of Oman. Those green triangles all are stations. The station, one of the station, yani this is simple station. How the setup is, they built a fence around the station, and you see that there is an aerial which is connecting to the satellites and sending the data continuously to the offices. And whenever there is anything, they can see it in real time. The data are coming to the office, stream to the office in real time. I tell you one story. They built such station somewhere, and there was a home nearby, somebody's home nearby. And after some time, that guy's home started to like see some cracks. So he went to the court and raised like against them, said that the reason my home started cracking is why they built something there nearby my home. And it was big story, but the case was won by SKU because they said we are not generating anything, we are listening, we are simply listening to what happens there. And they did for the investigation later on, from SKU. The SKU itself did the investigation, but our department. You know why his home started cracking? Because he built it on, يعني he brought some stone somewhere from somewhere and tried to make his home a bit higher. So the foundation wasn't solid foundation, was a man-made foundation. يعني جاب صخور ورمل وجابهم هناك. So he built his home based on top of a man-made foundation, not natural foundation. So his home was started crying. So the skill itself found that this is actually the reason why your home. When then he said yes, that's what I made. He said yes. I tried to raise my home a little bit. So I brought رمل وحصى وحاولت أرفع البيت شوي. This was simple. So these are the stations. The good thing, those stations are in jointly recording with other countries' stations. This is, we call it a network. Total number of stations is a network. And we receive event data from UAE in real time. We share our data with them too. In terms of seismic, Oman, this is earthquakes points. You see those points? They are color coded based on their magnitudes. So the plus sign, whatever you see, a plus sign is quite, sorry, the red star is the highest magnitude. Then the yellow square, then the green one. So those are the magnitudes. And Oman itself is aseismic. What is aseismic? I will tell you soon. But how I can correlate these two images together? I have two images. One is the image of the earthquake occurrences. The other one is the plate boundaries. This is the Arabian plate. That's the Euro-Asian plate. If you try to make a correlation between these two figures, you make a conclusion that those earthquakes are happening along those boundaries. We have a divergent boundary in the Red Sea. This is part of it is divergent, part of it. What type of fault are these? What type of this fault is? You see this fault or this fault in here in Masira?
Transform fault.
They are
Transform.
Yes, that's very simple thing you should know. So those are transform faults. This is a subduction zone. Whenever you see such a thing, this is means subduction. So Arabian plate is subducting beneath Eurasian plate, and the movement rate is 2 centimeter per year. Imagine just 2 centimeter per year. And most of the earthquake, the damaging earthquake for Oman, they are coming from Iran mostly, or this Zagros thrust or Makran thrust. These two are generating a lot of earthquake. The reason you see a lot of earthquake in Pakistan, in Iran, because of this zone. There are much lower number of earthquake to the this side, lower side of this subduction zone than to the upper part. Why is that? Because as we talked about, as you already have seen, this is how it works. The subduction, this is the subducting plate, Arabian plate, going beneath the Eurasian or Iranian plate. So the earthquake is supposed to happen somewhere down here. Oman itself is aseismic. Is considered, oh, this is, I should change it. It's not a seismic, one word. Aseismic means there is not much seismic activity. And we already have seen that the most of the earthquake they happen along nearby plate boundaries. And major of those earthquakes, they actually, whenever there is a major damage, I remember once I was in SKU, I was in here in this office. The Mr. Badr is sitting in this. There is an office here, and there was, I haven't felt it, but Badr felt. And Badr said, Khalil, haven't you felt the earthquake? I said, no. He said, can you see there was a water bottle? Do you see the water? It's moving. I said, yes, it's moving. And there is some shaking too. But I'm not sure. I haven't felt it. Uh, I ask you, how we can predict earthquakes? Is it possible to predict earthquakes? Uh,
Yes, doctor, yes.
yeah, there are some possibility. It's hard,
Yeah.
but
By animals. Yeah.
yeah, that's good answer. That's what my point was. So animals they feel the earthquake for some reason before it happens. How is that? Not sure. I have some video showing that case, but I might not be able to show it because we are left just for with 10 minutes or less than 10 minutes. So this is the seismic hazard map or acceleration, how much shaking happens. So you see in Oman most of the shaking in the Musandam area. And
Doctor,
yes,
can you explain for us how the animals can predict the seismic?
uh, it's the topic of research. No one knows. Someone I have to mute. Let me try who is speaking. I keep muting him. Anyway, so stays topic of research. Guy, I'm hearing my sound, my echo again. Someone, you should mute yourself. Okay, there are some extension in Zoom through which I can mute everyone. So it's the topic of research. Scientists they does not know exactly how they can like know whenever there is an earthquake. But mostly dogs and cats. Some animals, bears, they does not feel it for some reason. Not sure why. We might need to do some more investigation in this regard. But this is going back to our points. This is the hazard map. This is generated by Earthquake Monitoring Center. If I compare that one to the one generated for USA, there is a transform fault in California, which creates a lot of faults or earthquakes. You see, the red zone there is 4 meter per per or 4 meter per centimeter squared. That's quite high. The one in here is in here. For example, the red centimeter, let's say 160 centimeter per squared per second squared. It's way lower than what we see in here. How they generate these maps, you don't need to know. We'll not cover this thing probably, except at the end of this course. Earthquake and site characterization. I probably need, yeah, let's cover this one. So, whenever you try to build a very important building, what kind of important building? Nuclear plant. Nuclear plant. You need to do a lot of investigation to the area. So this is Mexico City. This is, we know that this is Mexico City. If you do a cross section, or if you draw a cross section along the Mexico City, you will find it's very active zone. There are a lot of deep-seated faults, faults extending up to the crust, up to the mantle or lithosphere. And the area itself is an ancient lake. So you see the yellow colored, this is very ancient lake. What difference it makes? If you build a home on a solid ground, on the mountain, on igneous rock, there is not much shaking. But on something which is not very stable, not consolidated, the shaking gonna be higher. And there is something called lithification. We'll learn about it later on. So try to avoid unconsolidated sediments whenever you're trying to build a very important building like a big hospital or nuclear plant. And don't build in very active zones. Whenever you know that there is a very active zone, don't build a nuclear plant. The last earthquake, which happened in 2011 in Japan, it was very devastating, and it damaged one of the nuclear plants, and there was a leaking of what they call them, إشعاعات, radiations. So they affected some people, and probably it will affect generations to come from those radiations of whatever uranium and other active minerals or active items. Another thing, dams. Have you heard of dams? You know what is dam? In Oman, we have dams. So whenever you build a dam, don't build it nearby an ancient fault. Dams themselves, they can create earthquakes. Why is that? Because they are storing a huge mass of water, and that water will exert a force on the surface of the earth. And if there is a fault down the ground, the water can leak through the fault scarp or fault surface, and it can lubricate it. It start then moving, and it happened in Egypt. In Egypt, they built a lot of big dams, and some of those dams they started creating earthquake and many other parts of the earth. So knowing how to assess the earthquake.
Doctor,
Yes.
can you repeat the last point?
The last point I was talking that whenever you try to build a dam, it's good idea to make some studies about the area where you want to build the dam. So make studies for example, if there is any old big faults, if there is any fault which is extending from the crust to the mantle or to the lithosphere, because those faults gonna be very active, then avoid building a dam there. And in case if you still need to build a dam, then don't make it very huge. Why is that? Because if you made the dam really huge, you might be storing a huge volume of water. You will be trapping water inland, onshore, and that water might put load on the earth and reactivate those old faults. They were not active very long time, but they're gonna be activated. How they gonna be activated? The water can go through these faults. The water go along these faults planes and lubricate it. Start then making movement. It might be like that's jammed together. There was no movement, but there are some forces acting. And whenever there is a lubrication, the weakest point, when earthquake happens, at what location earthquake happens? The weakest point in the rock. So avoid building a dam whenever there is probably some old seismic activity or some faults which are extending very deep into the ground. I stop here. I give you 5 minutes for any questions, but we still have some slides left. They are not much. We can cover them later on. So, do you have any questions for 5 minutes? Give me a couple of questions. The lecture is streamed right now in YouTube. It will be available soon.
Yes, Doctor. Why do we need to record earthquake for like 30 seconds or more?
30 channels? 3 channels, you mean?
No.
Ah.
The time for earthquake recording.
Oh, okay. Because their period is the CUDA is quite long. يعني you see the energy, the PS wave energy arrives after 5 seconds. If I record it just for 15 seconds, I miss the other part. But in reality, they are recording continuously. And the stations we have, they are recording every second. They are waiting for any shaking to happen. So they are not the one you see in oil industry. In the oil industry, the story is quite different. They are continuously recording. I will not go about the triggering. There is no triggering system. What I mean by triggering system is a system which expect that this waveform is from an earthquake. Start recording it, and if the amplitude increase beyond certain level, that level is the noise level. They start recording. They will not record continuously. Why they don't record continuously? Because you will be storing billions of data, and we don't want to store all of this data. We don't have the budget to store a lot of data. You need a lot of hard disk, many things to store and process this data. The processing is very expensive too. But in earthquake, because why is that? Why do I need just record it all? Because if I go to the map of Oman, where is it?
يلا كمان.
There are few stations. There are not much stations in them. يعني compared to like one of the fields I was working in. Small field they were more than 50 in small field. Compare it to what we have in here, which is very low number. I ask you a question: which is the country which has the highest density of stations? There is a station like every 5 kilometers. Seismic.
Maybe
Huh?
maybe Japan.
No. USA. USA has a lot of equipments or stations. The network use station network is really the strongest network. And another question, I ask you a question since you are not asking. Why there is no station in the interior part or central part?
Because it's not active,
It's not
maybe.
active, yeah. That's one reason. Another reason, why do they care? Yani, they don't care because there are not any inhabitants there. There are not a lot of buildings there, so they don't care. PDU has its own stations, but the station the PDU has, their style is or their instruments are different than the one SQ has. These are very broadband. What I mean by broadband, they record a lot of frequencies from 0 up to 1000, and the frequency limit they or frequency range they can record is really wide spectrum. I have written it somewhere, but I forgot to mention that thing. I think I have written it. Yes, a wide spectrum of frequencies. If you wonder what is the meaning of this thing, it means I record all of these frequencies. For example, the one we have in SKU, they record from 10 frequency up to 60. The central frequency is 40. We have some small geophones. We call them geophones. Their central frequency or resonance frequency is 40. They record from 4 to 10. They can't record earthquakes. The earthquakes they have very low frequency. The frequency below 10, probably 1, 2. I can't record earthquake using the geophones we have. We need very broadband equipment. They are very expensive too. Anyway, stop here. I exceeded my time limit. And if you have, yes, go ahead. Ask.
I have a question.
Yes,
A
what
few
was your
months,
question?
yeah, a few months they mentioned that there was a small earthquake on the Samail
Yes. We
because of the Samail gap, I think, or something like that. Could you please explain this?
there is an active movement going along there. They think that might be related to Maradi strike slip fault. That Maradi strike slip fault is cutting through almost half of Oman, from Masira region up to close to UAE border. And there is, they call even Samal gap. What is Samal gap? And I don't want to go into detail. Um, when ophiolite came on top of Oman, mostly when I talked about the rocks, they don't want to be compressed. When I compress them, they don't break. When the ophiolite came on top of Oman, the forces which were acting on that period were compressional forces. So they create long faults. The faults, they go from deep asthenosphere or deep-seated layers to the surface. They call them thrust faults. Those faults, they are slightly still active. The state does not know which might be the reason. Is it Maradi fault, or the reason for Samail activity or seismic activity in Samail is related to those thrust faults which were created during the Oman abduction period. So investigation is still going. Seismic methods, we use exploration seismic to detect the faults. They can't go very deep. They can't go below 10 kilometers. You cannot detect or map faults using seismic technique we use for oil exploration to detect fault beneath 10 kilometers. Those faults, the one they know that those are thrusting faults, or they call them detachment faults too. They are very deeply seated faults. They get active sometimes. But
Okay.
but compared to what we observe from Iran, these are minor things. Yani. We still are considered very aseismic. Aseismic means seismicity is very low.
So it is not an earthquake, it is seismic.
No, it's not seismic creep. It's an earthquake. The release of energy was sudden.
Okay.
People felt it, and there was small damage.
Okay. Got it.
Any more questions? No questions? So we leave it. Thank you very much. I'll meet you after 2 days, after one day, day after tomorrow.
Okay, thanks, Dr.